to this module where we are going to discuss about infrastructure as code. So what is infrastructure as code? We will be understanding it. It is basically a practice of managing and provisioning IT infrastructure using code rather than any manual process. So what type of code we have to write? What would be the format of it? What are the services provided to us on the AWS for the same? We'll be discussing about all of those things. So the very first topic that we'll be discussing about is cloud formation. Then we'll talk about Elastic Beanstalk, which is one service where you just need to worry about your code. The underlying infrastructure would be automatically created for you. Then we'll be talking about solution library. As the name is suggesting, there are some solution sample architectures already available. We'll be talking about CDK, that is Code Development Kit, and lastly, we'll be talking about Systems Manager. So if we talk about cloud formation, the very first topic we'll be talking about IAC, that is Infrastructure as Code. So with IAC, you can define and automate the creation, configuration, and development of infrastructure resources using the declarative approach. So we'll be discussing about benefits, we'll be discussing about best practices, we'll be discussing about tools and platforms that would be there for infrastructure as code. The next topic is cloud formation, the service which is provided by AWS for infrastructure as code. We will be talking about stacks, change sets, template anatomy. This template would be of cloud formation. So what is the anatomy of that? And lastly, if we don't want to write the code and what if I want the GUI interface, then I have the cloud formation design. So infrastructure as a code, we have already discussed that it is a practice of managing the IT resources in the form of code. So how we will be writing that code? Do we write it in Python? Do we write it in Java? We write it into either JSON or YAML. So we are actually not writing the application code over here, understand it. Here we would be writing the infrastructure code. So it wouldn't be executable file, it would be a template in which we would be defining that what architecture we actually want to create. So JSON is JavaScript object notification and YAML is yet another markup language. Both of these languages are really very simple. For example, if I talk about JSON, I can say that JSON would be something like this. Region would be, let's say that we can have US East 1. Right? So this is JSON language. You can have the codes over here. And then we have YAML. That is yet another markup language. So it would just be a simple language where we would be having resource and the name of resource. We'd be having region and the name of region. It is very similar to that of JSON, but we reduce these braces. So we can automate the creation and the configuration as well as the deployment of our infrastructure in the declarative approach. So we don't have to go to console and we don't have to write or we don't have to deploy those. Because imagine if I want to, deploy the entire infrastructure, then it would be really very difficult to go to console and create each and every service and then to give out the permissions. So human errors would be there in that. Okay, and it would be a complex thing to do. So these are some of the examples or the tools that are used for infrastructure as code. So you can see for AWS, we have AWS Cloud Formation. It provides us with the templates of JSON and YAML for deploying the infrastructure resources in AWS. If we do not want to just, if we just want a generalized example, then Terraform is one of the example. So it is an open source infrastructure as a code tool that allows you to create, manage, and version infrastructure in a safe, predictable, and repeated way. It was developed by HashiCorp and is designed to work with variety of infrastructure providers including AWS, Azure, GCP, and many others. With Terraform, you can define your own infrastructure as code using the declarative language called as HashiCorp Configuration Language, that is HCL. So this allows you to specify the desired state of your application or infrastructure, and Terraform will automatically make the necessary changes to ensure that actual state machine matches the desired state. So that is about Terraform. Next, we have Ansible. Okay, again, one generalized example, not related to any of the service of AWS. It is again open source automation tool that will allow you to automate the configuration, deployment, and management of IT infrastructure. This was developed by HashiCorp, and this is developed by Red Hat. It is designed to be simple, agentless, and powerful. So with Ansible, you can define your automation task using YAML syntax. Okay. So that's about Ansible, guys. Next, we have chef recipes, right? So this is something different. If we talk about chef recipe, right, it is configuration management tool for automating the infrastructure deployment. So it allows you to automate the configuration, deployment, and the management of IT infrastructure. In Chef, a recipe is a collection of configuration instructions that define that how do you want to configure specific part of your infrastructure. Chef recipe is basically written in Ruby DSL, that is domain specific language, and it consists of series of resources which are built using the building blocks of Chef configurations. So Chef recipe can be combined into cookbooks, which are collections of related recipes and other configuration files. And these cookbooks can be shared and reused across different infrastructure environments. And the last topic, or the last tool that we are going to discuss about is Puppet. It is also a configuration management tool allowing you to automate the deployment and management of IT infrastructure. In Puppet, a manifest is a configuration file that defines the desired state of your infrastructure. It is written in a declarative language that would be describing the resource on a node. Okay. And Puppet manifest can be combined into modules. Just like, chef recipes can be combined into cookbooks. Puppet manifests can be combined into modules, which are collection of related manifests and other configuration files. Again, these modules are shareable and can be reused across different infrastructure environment. So these are all the different tools that we have for infrastructure as code, the generalized one as well as specific to AWS. Now, what are the benefits of infrastructure as code? So the benefit is you can replicate and reuse this. For faster and more reliable deployments of infrastructure as code, you can use this particular method of creating your infrastructure. Next, it also has version control. If we take the example of replication and reuse, we would be just seeing in the next slide, okay, how this replication and reuse will work. Then version control. So if you have created already one template for creating your infrastructure, okay, then you made some changes to it. Then storing different versions and using the latest version on a specific version is possible on infrastructure as a code. So version control is also there. You can use this for continuous integration and continuous deployment strategy as well. Because not only developers, architects also use this particular strategy. As the template of infrastructure that we have created changes, we can also change the infrastructure that is actually there. So CI/CD pipelines can also be created with the help of infrastructure as code. It can detect the drift. For example, you might have created one infrastructure in which you have VPC, in which you have two subnets, okay, and you might have one EC2 instance, and this EC2 instance might be having one security group as well. So this security group, if I'm changing some configurations of the security group, then that is called as drift. That my infrastructure has drifted a little bit or changed a little bit than my original configurations. So that is called as drift. And if there are any changes from the original deployment to the deployment currently which is there, then that drift can be detected. You can roll back to the last good state. You can, if some errors are occurring, okay, while you might have made some changes and those changes were not applied successfully. So will your entire infrastructure go down? No. What will happen instead is you can roll back to the last good state of your infrastructure, which will allow you to handle the failures of infrastructure updates very well. So now let us see that what is the reusability concept. Suppose you have created one infrastructure into region 1. You have created some infrastructure like, some VPCs, some subnets, and some EC2 instances. If you would have created such kind of infrastructure over here, and then your boss says that, okay, this infrastructure is working fine for the development environment in region 1. But now I want to create the same infrastructure in region 2 for the production environment. And what will happen over here is either you have to remember all the details of what you have provisioned, or you should be having one solid documentation if you want to manually deploy the resources into another region. So instead, a better option would be to use infrastructure as code. So it gives us the reusability. If I already have one template created with me, which I used for creating the infrastructure in region 1, I can use that template for creating the infrastructure in region 2 as well. So I can reuse this. That's why the burden or the burden is reducing, right? I'm not doing the same work again and again. Instead, I have already a template and I can use that template in deploying the infrastructure into multiple regions. So this template would be in the JSON or YAML file. We are talking specifically about AWS. So this would be a cloud formation template. The next thing is, if we want to make any changes to our infrastructure, then if I wouldn't have this template, then what I have to do? I have to make the updates manually into all the regions. Even if I have the same infrastructure in both the regions, I have to make the updates manually. So to avoid that, we can use the templates. We can just make the required updates into the template, and that template would be then deploying those updates to the infrastructures into multiple regions wherever that template is applicable, and wherever we have created the resources or the infrastructure using that template, it would be updated. Cloud formation is basically a service which will allow you to model and provision AWS resources using templates. Okay. So with cloud formation, you can create and manage AWS infrastructure in repeatable and automated way. So we already know that, right? We don't need any manually configured resources. So what are the features of cloud formation? It is infrastructure as code, which uses JSON or YAML simple syntax. So it is very easy to use the syntax and to create a template and to deploy our infrastructure. Automated provisioning is there. It means that once we have uploaded the template to the cloud formation, it will automatically deploy the resources and it will automatically provision the resources. It will make the API calls on our behalf. So cloud formation would be making the API calls to all the resources that are being defined in our template. It can do the resource management. So if you want to manage your resources all together, then it is really useful if we use the cloud formation. If you delete the cloud formation stack, all the resources created with it can be deleted, right? So that management becomes very easy. We get a single place for managing our resources. There are easy rollbacks. So if you want to revert your infrastructure to your previous states due to any kind of issues, then that can also be done. So how it will basically work? So when we talk about cloud formation, then we have to first of all define a template which will be using a JSON or YAML file. Then we will be creating a stack. It means that we'll be uploading the template to the cloud formation and a stack would be created. What is stack? It is a set of AWS resources that are being defined in the template. So let's say if I have EC2 instances, if I have RDS database, if I have VPC, if I have a DynamoDB, then this would be creating my stack. We can update the stack. We can make the changes to the template or add and remove resources and update the stack to apply the changes. So once we apply the changes to the stack or the template, right, it would be deployed or updated everywhere. We can delete the stack to remove all the resources created by cloud formation. Now, what if we don't want to do that? If I delete the stack, the resources should not be deleted. Then also you can do it. You have to specify that. So this is how the actual scenario would look like. This is our template. The template would be uploaded to cloud formation. Now where this template would be there, I can either browse this template from my computer, or from your machine you can browse it, or you can store it on S3. Here also you get some sample templates. If you want to deploy a common or very common architecture, then you can just go to that sample templates and you might find the architecture already there, or the template already there for the particular architecture. Or you can create your own custom templates as well. For creating the template, we have again two ways, or say three ways. You can either write the JSON code, you can write the YAML code, or you can use the designer. So the template would be uploaded to the CloudFormation. The CloudFormation then would be creating this template in the form of stack, that is a group of resources. And whatever resources are being mentioned into that template, the API calls to those resources would be made with the specifications that we would have specified. So this is how the entire thing would work like. Now what is stack? So stack is nothing but the collection of AWS resources that are created and managed together as a single unit using the CloudFormation template. So when you create the CloudFormation stack, you basically define a template that specifies the resources you want to create or configure. CloudFormation will provision these resources and configure them accordingly to the template. If you say that security group should allow SSH traffic, then that would be configured. If you say that you want to block traffic from HTTP in NACL, then that would be configured. So this will manage the entire life cycle from creation to deletion. CloudFormation stack can include variety of AWS resources such as EC2, RDS, S3, DynamoDB, etc. So these resources can be created, updated, deleted together as a single unit, because that is what the stack is all about. So it provides us with a consistent and predictable way to manage our infrastructure. Now stack can also be nested. Let's say that if you want to create a very complex infrastructure, then writing everything in one template or putting everything in one stack would be tedious. Debugging that would be difficult. Making changes to that would be difficult. That's why we can also have nested stacks. This will allow you to create complex infrastructure configuration that will be consisting of multiple stacks. Like for a database environment, you can create one stack. Then for application servers, you can create another stack. For your web servers, you can create another stack. So different multiple stacks can be used. So this enables you to modularize your infrastructure template and reuse them across different projects or environments. Using CloudFormation stack would provide you with several benefits such as improved consistency. So I will just try to delete everything from slide and we would be writing the advantages over here. So what we'll be getting? We will be getting a good consistency because everything is managed as a single unit. We would get faster infrastructure provisioning. The management would be simplified. So these are all the benefits that you can get along with Stack. Additionally, you can have your version controls, you can track the changes, you can easily replicate the infrastructure in other environments, right? So this is all the stacks are about. The next topic is change set. So change set is nothing but a preview of changes that will be made to an existing stack when any update is being executed. So if you want to see that what are the changes and how it will affect my infrastructure, then you can create one change set. It allows you to review and approve the changes before they are made to the stack and actually deployed. So it will provide additional layer of control and prevent unintended changes. When you create the change set, CloudFormation compares the current stack with updated template and will generate the list of changes, including any kind of additions, any kind of deletions, or any kind of modifications. You can review these changes and make any necessary modification before executing the update. So any unintentional changes can be avoided over here. So change sets can be created for any CloudFormation stack, including those created using templates authored by others. So even if the stack is created by person A, change set can be created by person B. That is fine. This allows you to review the changes that others are proposing to make to shared resources and provides an opportunity to catch an potential issue before they occur. So suppose I am the author, okay, like A person is the author of the stack and B person is trying to change it. So he will propose a change set and I will be reviewing it before actually deploying those changes. Again, there are few benefits of change set. Those benefits are we have improved visibility into our changes. Okay. Then we have increased control. Control is increased over updates. We have reduced the risk of failures in case of unexpected changes or modifications. Additionally, change set would allow you to preview the changes. You can test updates in the safe, isolated environment before actually executing them on the actual stack, reducing the likelihoods of errors or disruptions. So this is one of the very good feature that you can test your changes in isolated environment and not the actual environment. So this is about the change stack. The next topic is template anatomy. So when we discuss about AWS CloudFormation template, it is the building block of AWS infrastructure. It can be created, I'm reiterating it again, it can be either created in JSON, that is JavaScript object notification. It can be created in YAML, that is yet another markup language. Or it can be created using Designer, which is the GUI for creating the resources. The anatomy of CloudFormation templates includes various key elements. We are going to discuss these key elements one by one. So first of all, we have to specify the version. Version is basically, it is the version of CloudFormation template language that we are using. So this one is the latest version of 2021. It was for 2021 and it supports all AWS resource types. The next element is description. You can provide a description of CloudFormation template, which will help you understand what is the purpose and the content of this particular template. The third parameter is to define the input parameter. Okay, so basically the third element is parameters. During the runtime, if you want to take some values while executing that particular template, you can use this particular element to define the input parameters for the stack. For example, if you are creating the EC2 instance using the stack, then what type of instance you want to create, the instance type. If you want to take that during the runtime, then you can do it. There are mappings. So these mappings are used to define mapping of the key to corresponding values. For example, if we want to map the specified AMI IDs for different regions, then we can do so. Because AMI IDs do change according to the regions. So we have to create a mapping for the same. The next element is condition. If you want to specify that if some condition is being met, then only you want to create the resource, or else you don't want to create it. Then in that case, you can use this element to determine whether or not certain resources are created or not. The sixth element is resource, which is the compulsory part of your template anatomy. If other elements are not there, it's fine, but resource is the compulsory element of your template. It will basically define the resource that you want to create and manage using the CloudFormation stack. It will contain the resource type, its properties, and all the configurations. So obviously with the CloudFormation stack, you are deploying your resources, right? So this would be a mandatory thing for your template. Then we have outputs. So this element will define the output values of CloudFormation stack. So this would be, which it basically, gives out the output once all your resources are being created. So why this can be used? It can be used as inputs for other stacks or applications. If you are using the nested stack, then it can be used for that. Or let's suppose that I was creating one environment where I have the elastic load balancer, and on the back of elastic load balancers, I have EC2 instance running. So now I've created this web environment, okay. So if I want to connect to that environment, I'll require the DNS name of the elastic load balancer. So I can produce the DNS name of elastic load balancer in output. And lastly, metadata is there. So this element will provide additional information about the template, such as who is the author, what is the version, any kind of license. So that would be contained into metadata. So these are all 8 different elements that we have for CloudFormation stack. Now let's take a look at one example for better understanding. So this is the template created in YAML program or YAML language. So you can see that we have the version, we have description. So version is this, the description says that it is creating S3 bucket with public access block configuration. What are the parameters that we are giving? So the parameter is bucket name. So user have to give the bucket name in the input while this stack would be, or while this template would be uploaded to the cloud formation. Then we have resources. So I'm creating my bucket. The type is S3 bucket. The properties are bucket name. Where the bucket name would be coming from? It is having some reference, as you can see. And the reference is given to the bucket name. So this bucket name would be consisting the value which user would have provided in the input while deploying this particular cloud formation template. We are blocking all the public access. So we have given the block public ACLs as true. The block public policy is also true, and we are saying ignore public ACLs as true and restrict public buckets as true. So all the public access is being denied over here. And lastly, in the output, we are giving again the bucket name, which is again referred from my bucket. Now, what is this my bucket? It is the resource name over here. Right? This my bucket would be containing the bucket name, which was provided to us in the input. And the description would be the name of S3 bucket created. So this is a very simple example, right? It is a very small YAML template. We do have huge YAML templates where we might have, the mappings as well. We might have some conditions as well. So it depends up to the complexity of the infrastructure that you are trying to create. The last topic is the cloud formation designing. So when we talk about the cloud formation designer, it is a tool, it is a visual tool, a GUI based tool, a simple drag and drop environment where you can create, view or modify your cloud formation templates. So if I do not want to write the JSON or the YAML code, then I can use this designer for creating my infrastructure. So this designer would be helping you to visualize your infrastructure or architecture. You can see the visual representation and the relation between your resources in the template. It allows you to easily understand the architecture and dependencies in your infrastructure. You can have a simple interface for creating your template using the drag and drop model. You can also create template from the scratch, or you can import the existing template and make the required changes. It validates the template before deploying. So it will validate the syntax of your template, highlighting any kinds of errors or warnings. This is helpful when we want to avoid any kind of issues when we are deploying our infrastructure. You can collaborate with your team members. The designer will allow you to share the templates with team members and collaborate on the changes to the infrastructure. So this will improve the team communication and ensure that everyone is on same page. If you want to export this, then also you can export your templates in JSON or YAML format, which can be used for automation and version control. So on and on, the designer can simplify the process of creating and modifying the cloud formation templates, allowing you to focus on designing and building your infrastructure rather than, writing the complex code of JSON or YAML. So it would just give you a basic drag and drop environment, which is actually very easy to use. If you once understand it, yes, there are different components to it. Like if you want to add a security group to the EC2, then how to do that? If you want to create the relation between two services, if you want to give the permissions, right? Then how to do all of that would be given into the documentation. But Yes, it would be easy once you understand it. The next topic is elastic beanstalk. So when we talk about elastic beanstalk, we will be talking about, first of all, about the service elastic beanstalk of AWS and the web and the worker environment that it creates. So elastic beanstalk is a fully managed service which makes it easy to deploy and scale web application and services which are developed with Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker on popular web servers such as Apache, Nginx, Passenger, and IIS. So what this entire statement means is you simply need to give your code and your code would be deployed onto your AWS cloud, and you don't have to worry about HTTP server, app server, interpreter, OS, host. This would be entirely taken care by AWS. You are only responsible for your code. How cool it would be. Just give your code, the environment would be created for you. Don't worry about anything at all. And it supports, various programming languages and popular web servers as well. So that's the added benefit. So you can create two types of environments, web environment or the worker environment. With Elastic Beanstalk, you can easily deploy, manage applications without worrying about underlying infrastructure. It will automatically handle the capacity provisioning, load balancing, application health monitoring, and scaling. So look at the benefits of this. If we talk about benefits, then it is easy deployment. It easily allows you to deploy your web application using a variety of deployment methods such as console, CLI, or even Git. Auto scaling can be easily done. It will do it automatically. Okay, you don't even have to set the auto scaling group or anything. So you can set the thresholds for CPU utilization, network traffics, or other metrics just to trigger your auto scaling action. It will make your application highly available because it provides built-in redundancy and fault tolerance. Monitoring and logging facility is also available. So the detailed monitoring or detailed metrics and log of your application would be monitored using the CloudWatch. Platform upgrades are done. So Elastic Beanstalk would be automatically applying the security patches, updates, or any kind of bug fixes to the underlying operating systems and the web servers, keeping your web application up to date and secure. Lastly, you have cost effectiveness. Elastic Beanstalk would be only making you pay for the resources you are using without any kind of upfront cost or long-term commitments. So overall, it will simplify the process of deploying and scaling web applications and services, allowing you to focus on developing your application and delivering values to your user. So you don't have to worry about anything apart from your code. But AWS suggests not to use this in production environment. For production environment, it is good if you use the cloud formation. So, two types of environments can be there. The web environment, which is used for hosting the web applications that are accessed by end users through a web browser. Okay, on the internet, these environments or these applications would be accessed. So it is designed to handle the incoming HTTP or HTTPS traffic, and it will distribute across web application instances. Obviously, only one instance won't be there, right? We would be having multiple EC2 instances, and into those instances, the traffic would be balanced. So what would be the domain? Then it would something look like this: myapp.elasticbeanstalk.com. You can give here any name of your choice. So as you can see over here, we have route 53. It would be routing the traffic to the elastic load balancer. The elastic load balancer, this is basically our VPC. This is our availability zone. And these are our subnets. So elastic load balancer would be distributing the traffic between our subnets where we might have multiple EC2 instances. So this environment is called as web environment, and this would be created by Elastic Beanstalk automatically once you give your code. Right? The next environment that we have is a worker environment. So the web environment would be only able to receive the internet traffic. But what if I want to run background tasks as well? So if you want to run the background task and you have some application logic on your web application, then you have to create worker environment. So the web and the worker environment would be decoupled using the SQS queue, that is simple queue service. We would be decoupling the environment using SQS, and worker environment is designed to run long running asynchronous tasks that can be triggered by messages in a queue. So these environments are typically used for video encoding, image processing, or sending the email notifications. Both the environments would be having automatic scaling, load balancing, monitoring, and deployment capabilities. But in worker environment, we do not have a web server or load balancer because it is not designed to handle the internet traffic. Okay, it is used for application or say background tasks. It is used as app servers or background tasks. So instead, they are optimized for processing tasks and messages from a queue. So what is queue basically here? You can understand it that there is one, restaurant. So in that restaurant, all the waiters take the orders. So you cannot give the orders directly to the chef because there would be so many orders coming in. So we can just put it on bulletin board or we can just put it on paper. Similarly, when the traffic is coming from elastic load balancer, basically from the internet, and it is going to our web server environment, okay, this is web environment and this is worker environment. This is our worker environment. So whatever requests are coming to the web environment would be sent to a queue. It is just like a queue in a mall, right? So all the messages would be stored into queue, and from this queue, the worker environment would be reading those requests and would be processing it. So this is called as decoupling. So we have divided both the environments so that the incoming request, even if the incoming requests are high, then the worker environment will not get overwhelmed. Okay, so this is how the worker environment and the web environment work in Elastic Beanstalk. The next topic is solution library. So it is collection of vetted AWS solutions architectures, best practices that you can use for building and deploying your applications on AWS. So it is a library containing variety of reference architectures, white papers, that is nothing but the documents, the code samples that will provide you with guidance on how to implement common use cases and solve the complex problems on AWS using the AWS services. So it covers a wide variety of topics, like you will be getting basically the reference architecture, white papers and code samples for compute. So this would provide you the solutions for running and scaling application on EC2, Lambda and Fargate. You would be getting the service, you would be getting all these resources for storage. So it would be helping you to create the solutions for services like S3, EBS and Glacier. You would be having for database like RDS, DynamoDB and Redshift. Networking solutions would be there for designing and implementing secure, scalable and highly available network architecture. Security domain would be there for securing applications and data on AWS, including compliance and regulatory requirements. Analytical solutions would be there. So with analytical solutions, you can use it for processing and analyzing the data at scale, like EMR, Athena, and QuickSight. Machine learning solutions would be there for building and deploying machine learning models on AWS with services like SageMaker and deep learning AMIs. So by leveraging this solution library, you can accelerate your application development and deployment by using the pre-built architectures and the best practices that have been tested and validated by AWS experts. Sometimes it happens, right? We are doing nothing new. Most of the time when we are creating the web environment, it would be same for almost every firm. So those kind of architecture, if they are already available, then why to create a new one? Sometimes it may happen that we might miss something in creating the architecture, right? We might miss applying the best practices. So by using these templates, those best practices would be already in place. So we can ensure that, okay, we would be following all the best practices and our deployment would also become quick because we are using the pre-built templates. And these are also validated by AWS experts. So leveraging the solution library would also help you reduce the time to market, increase the application scalability, availability, and security, as well as compliance. The next topic is CDK. It is Cloud Development Kit. Now, what is this and what is the requirement of it? So CDK is an open source software development framework that will allow the developers to define the cloud infrastructure in programming languages. With CloudFormation, we saw that we can define the infrastructure in either JSON, YAML, or designer. But no, I am a developer. I just know, programming languages. So just give me a way to create the infrastructure using programming language. So the CDK is a way. It is development framework, okay? So it will support the programming languages as TypeScript, Python, Java, and C#. So with CDK, developers can use object-oriented programming principles to define the cloud resources rather than writing the code in YAML or JSON. What are the benefits of this? Benefits is you get the familiarity of the programming language. So CDK will allow developers to use their preferred programming languages and leverage the full power of modern IDEs debuggers, and source code control systems. Object-oriented programming language principle will be followed. So, to define the cloud infrastructure, which can help improve code organization, reusability, and maintainability. High level of abstraction would be there because developers are defining complex infrastructure using fewer lines of code, reducing the risk of common errors. Custom construct means CDK allows developers to create custom construct that encapsulate common patterns and practices for their organization, making it easier to standardize infrastructure and to share the knowledge across the team. Testability is there, so CDK allows the developers to test their infrastructure code using standard testing frameworks and practices. So this will again reduce the possibility of the errors. Lastly, we have integration. So CDK integrates with AWS services such as CloudFormation, Cloud Pipeline, Code Build. Sorry, not Cloud Pipeline, it would be Code Pipeline, Code Build, making it easier to deploy and manage infrastructure as the code. So it simplifies the process of creating the infrastructure, allowing developers to focus on building and delivering value to their customers. So these are the different advantages or benefits of CDK. The last topic that we have over here is Systems Manager. So this is a very important tool for managing the EC2 instances all together at one place or even the on-prem servers. So the content that we are going to cover we'll be talking about the Systems Manager service of AWS. We would be talking about the key features of it and the benefits of Systems Manager. So let's get started with the first topic. So Systems Manager is a service that helps you manage your AWS resources. It provides you the unified user interface so you can view the operational data from multiple AWS services and automate the operational tasks. So generally this is a service used by system operation team. Okay. So it helps you to manage your EC2 instances, on-premises servers, virtual machines through a unified interface. So if you want to automate common administrative tasks like patching, configuration management, resource inventory, then it helps you to do so. It is a centralized location for viewing and controlling your AWS resources. So what are the benefits of this, or what are the key features? So the feature is inventory. What is inventory? You can see and manage all your resources at one place. Just like we have the inventories for e-commerce, right? So they can just store every product at one place. So the same thing applies over here as well. You can see all your resources at one place. If you want to patch your instances of Windows and Linux, right? Then you are provided by Patch Manager. That too can be done once across multiple resources or multiple instances on a window, on a maintenance window that you want. You can have run commands running on your instances, including scripts without needing to connect to them. Okay, so Systems Manager agent would be there. Obviously, you have to attach a role with EC2 instances for, taking the advantages of Systems Manager. But we can run several scripts onto the EC2 instances all together on multiple instances. The State Manager is there, which will define and maintain consistent system configuration across the instances. If anything goes out of order, it would be notifying you. all the repetitive tasks can be automated, such as patching, running some scripts. Okay, all of these can be automated with a single click. All these tasks are done on the scheduled time which is being chosen by you. So you can run it at a specific time by creating the maintenance window for backups or patching or for running any command, etc. So these are some of the features of your systems manager. What are the benefits of it? So the benefit is we get the inventory. So it would be a centralized location for operational tasks. So all your resources can be having, this operational tasks going on centrally. We would be reducing the time and efforts required for the operational task by automating them. We have improved security and compliance tracking for our resources, and we can maintain the consistent configurations throughout. We can scale efficiently by automating repetitive tasks and managing resources at scale. So these are some of the benefits of our systems manager, right? So now we have seen all the theory portion of this particular module, automation, or say infrastructure as a code. Now we have to understand few things on the portal. So for that, I'll be taking you to the portal. So I am on my AWS portal. We are going to CloudFormation very first. Okay, so I'll simply go to CloudFormation from here. And you can see we have several stacks created over here, but I would be creating a new stack. What is stack? The resources that are being managed together as a single unit. So I will create new resources. You get 3 options for preparing your template, whether your template is ready. So as we have discussed in slide, you can give the S3 URL, or you can upload the template from your laptop or from your machine. Do you want to use the sample template, or do you want to create the template in Designer? So I'll go with the sample template over here, and we have to choose a sample template. So let's say that I would be selecting this WordPress blog, or let's go with the LAMP stack. So what this stack would be having, it would be using a single EC2 instance and a local MySQL database for storage. You can view this in Designer for better understanding that how this template is looking like and what all resources do we have. So you can see over here, we have web server security group and we have one web server instance. And at the bottom, you can see that we are having this same infrastructure in the JSON format. So we would be having the parameters over here where we would be taking the key pair name. We would be taking the database name, the database user, the password, root password, the instance type, SSH location. All of that would be taken in the input as parameters. We have the mappings for architecture type. Okay, different architecture or different instance type would be having different architectures that we need to map together. Then we are creating into the resources, we are creating the web server instance, that would be one EC2 instance. Okay, and we have to install and configure something over here. And these are all the packages that we want to configure because this is a LAMP stack that we are creating. Okay, this is our page that would be displayed, right? So all of this would be coming under the resources itself. Then we have some properties. We are finding the image ID for that EC2 instance in regional architecture. We are finding the instance type architecture in the instance type mapping that we have created. We are taking the reference of security group as well. The key name would be coming from the parameter. The user data is this. So this is the entire architecture. So you can see the JSON file is quite long, and here also all those configuration details would be added. You can see depends on parameter is there, right? Security group egress is there, security group ingress is there. So all of this we have to configure. So once it is done, you can simply close this. Okay, we would be leaving this designer. Okay, I have closed the entire thing. No worries, we'll start it again. So I'll be using the sample template. This time we will not go to the designer. I'll go to next. You have to give the stack name. Let's say demo stack 1. So I have given the passwords over here. I have given the instance type as T2 small. The key pair that I'm using is sample1, and the SSH location is from anywhere. We'll go to next. If you want to add tags, you can add it. IAM rule is the optional thing. I don't want to add anything. If the stack failure happens, then what do you want to do? Do you want to roll back all the stack resources which were created, or do you want to preserve the successfully provisioned resources? So I want to roll back all the stack resources. Then we would be just going to next. This is the review. So we have this template over here. These are all the details that we have specified. No tags, no permissions, etc. And we will submit this. So as soon as we submit this, okay, the DB password failed to satisfy the constraint. So let me just check this, and I'll edit this from here. Okay, so I have changed the password, and I have submitted the stack. So you can see the creation in progress. Okay, so you can go to stack info over here. It will also show status as creating in progress. If you go to resources from here, you will see that what all resources are getting created. Okay, so the security group was created. EC2 instance is getting created. If any outputs would be there, it will be shown over here. Any parameter values, so we have given the parameter values which are being shown here, right? The template that we have used, it is shown here. Change sets, we do not have any change set as of now, right? So it is not shown anywhere. Into the events, we can see that web server security group got created, web instance is getting created now. If we go under the resources, it is creation in progress. So we have to wait for some time for this to complete. Okay, so as you can see over here, the creation is complete. Here it is showing creation in progress. We can just refresh it once and creation is complete. If you go to stack information, you can see create complete, right? And if I go to outputs, let's see if we get something. Yes, we are getting the website URL, right? It is the URL for EC2 instance. So let me just click this and see what we are getting. So this is what we are getting. Welcome to AWS Cloud Formation PHP sample. This was the LAMP stack, if you remember. And these are all the details that we have over here. Right. So this is how you can use your cloud formation stacks for creating your resources or deploying infrastructure automatically to the cloud. Okay, now what will happen if I delete this stack, okay, the demo stack, then all the resources, first of all, let me also show you one more interesting thing. EC2 instance would have been created into our EC2 console. So I'll just go to the EC2. we go to the running instances, you can see this one. This is the instance that is created using the CloudFormation stack. Okay, demo stack 1 web server is the security group that we have attached to this. Security group and other things would also have been created here, but I'm not going into that details. I'll just select this and I'll say delete the stack. Okay. According to the deletion policy being applied, the resources would be deleted. So as I told you, if you delete the stack, all the resources with that stack would be getting deleted because we are managing the resources as a single unit by creating the stacks. But if you do not want that, if you do not want the resources to be deleted, you can have the deletion protection as well. So that will protect your resources from getting deleted when the stack is deleted. So as of now, I do not have any deletion protection on. So you can see that no instances are running so far. Okay, means that instance got deleted. So if you just try to refresh it, you will see deletion in progress. Again, you can go to events and see what all events are happening. So demo stack 1 deletion is being in progress, right? Everything would be deleted once this would be done. Can go to stack information and delete is complete. So we have successfully deleted all the resources and the stack as well. Okay. So this was the demonstration for CloudFormation. Okay. Okay, so now we are going for the Elastic Beanstalk. So I am into the Elastic Beanstalk console. You can see it manages end-to-end web application management. Okay, so we will just go to create application over here. So I want to create the web server environment which will be running a website, web application or web API that will be serving the HTTP traffic. If you want worker environment, you can create so, but right now I'll be going with the web environment. I'll call this as demo app. Okay. The environment name would be demo app environment. The domain, you can leave it blank for auto-generated value, or you can put the values over here and you have to check the availability because it should be unique, right? So I'll just keep it blank. I'll not put any description as well. Let's just put description only. It would be the managed platform and I want to make it for Python. Okay. Python 3.8 is fine with me and the platform version is 3.5.2. Okay, onto the Linux it will be created. I want to deploy the sample application. I don't want to upload my code as of now. I want it as single instance. Okay, I do not want to make it high available or I don't want multiple instances over here. I just want single instance which is good for free tier eligibility. I'll click on next. Then service role. Do you want to create a new service role or do you want to use the existing one? So we can select a new service role and it will automatically create it. What is the key pair that I want to use? Sample 1, so that whatever EC2 is getting created, if I want to SSH into it, I can. Okay. Next, this is fine. So we'll go to next. Into which VPC do you want to launch it? So let's say I want to go with my VPC over here. Okay. Into which availability zone? I can just go with any availability zone. I want to activate the public IP address of it. Do you want to enable the database? So no, I don't want to enable database as of now. If you want to have tags, you can have it. Okay, let us see what is the problem. I think US East 1E wouldn't be supporting the instance type. So let's just keep the VPC as empty and we want the public access enabled. Let's click on next and see what happens. Okay, good. So root volume would be container default, right? You can go with SSD, GP2, GP3 or IOPS or magnetic. So you can go with anything. Let's say I want to go with the GP2, then the size would be 8 GB, right? Instance metadata service, you can deactivate it or activate it according to your requirement. The security group that you want to apply. So let's say I'll be going with public security group. Auto scaling, do you want it or not? So it would be a single instance. So I don't want any auto scaling. It would be on demand instance, right? I don't want spot instance to use it. T3 micro or T3 small would be the instance type. This would be the AMI ID. Okay. And once it is done, we can just click on next. Okay, the size would be between 10 or more. So we just put the 10 GB size for volume and we'll be going to next. Once everything is done, we can review everything. Okay. So health reporting, I just need the basic health reporting over here, nothing more. Do you want to have managed updates? So I don't want any managed updates over here. Any email notification if you want? No. What would be the update deployment? How the deployment policy should be working? I'll be talking about this deployment policies later. So right now, let it be all at once. Rolling update is deactivated. That's fine. We'll be talking about it later. Okay, Nginx is the proxy server which would be created. I don't want to have X-ray debugging over here. I don't want to store the logs in S3. I don't want log streaming to CloudWatch. Okay, this is the Python path for our environment variable. We need the Python path, right? So that is being given over here. We will be just clicking on next. Everything seems fine. So once everything is being done, you can just review it. And lastly, we will be submitting this. So the role name Elastic Beanstalk service already exists. So where it was, here it was. So let's edit this. Okay, now we'll skip to review because it is already existing. I said use existing service instead of creating new one. Okay, and now let us try to submit it and see if it works. Yep, all good. It is launching environment. It will take few minutes of time for running this. Okay, so we have to wait for that time. So as you can see it over here that our environment is ready, right? You can see that it is healthy in green. So what we'll be doing here, we will be just going to that environment URL. You can see congratulations, your first Elastic Beanstalk Python application is now running on dedicated environment, right? So if you want, you can just go to these documentations as well, and it will redirect you to the documents section of AWS, right? So this is how the Elastic Beanstalk work, everyone. It is kind of a very interesting thing, right? All the events that happened while creating this environment. Okay, let's check into EC2. What do you guys think? Will EC2 would have been created over here or not? So let's check that out. If we go to the running instances, we have one demo app environment instance running over here, right? So obviously it will get created because it deploys the infrastructure automatically, right? We have just given the configurations and the infrastructure was automatically created and we are running this particular website on it. So if you want, you can have your own code as well. Right now, this is just a sample code that I've used. You can give your own code and you can run that code onto your Elastic Beanstalk without worrying about the underlying infrastructure. So this was about the Elastic Beanstalk. Lastly, we will be seeing one demonstration for running the commands on Systems Manager. Okay. So we would just check that out once, and after that, this module would be officially ending. This is the demonstration for our systems manager. Okay, so we are going to run a script basically, run a command on all these four instances that I'm about to launch. Okay, so as you can see, I'm launching four instances over here. I'm just naming them SSM demo, right? I'm using the Amazon Linux AMI, the latest one. And the other things that I'm doing is I'm using T2 micro. That is fine. It's free tier eligible, right? I'm using this key pair. So we won't require SSH for this, but still I'm using the key pair for the same. I'm launching them into the public subnet of my VPC where I have one security group already created. So I have chosen that security group, right? So I'm using this default root volume of 8 GB. And apart from that, I have to give one IAM instance profile. Means I have to give the IAM role to this EC2 instance so that it can communicate with the systems manager. Okay, I already have one role created over here, right? We have already seen in our previous demonstration how to create the roles. So this is SSM role for EC2 that I'm attaching it over here. If you do not have, you can create a new rule for the same. This is the managed policy, AWS managed policy that I've directly attached to this role. Apart from that, I think everything is fine. I don't want to make any changes here. So what we'll do is we'll be launching this instance into the public subnet with the public security group with it. Okay, so four instances would be launched over here. So till the time the instances are launching, we'll be saying, okay, let us filter this by the running instances. Okay, the state of instance should be running. They'll be soon coming over here. They would be into the pending state. After some time, they'll be into the running state. So let's wait for that time. Okay, so now you can see that all of our instances are into the running state. Okay, so I have four instances over here. They are into this availability zone. Fine, this is good. So I just want to wait till the time, the status checks are completed. And after status checks are completed, we'll go to the systems manager. Okay, so as you can see, the status checks are done now. What I will do is, I want to do one thing over here. I'll select all these instances and I'll go to actions, and into the actions, basically I want to manage the tags, right? So I'll just be providing the tags to each one of this instance. I'll go to actions again, instance settings, and into this I'll be managing the tag. Okay, so name is this SSM demo, that is fine. But I can also enter one more tag, let's say environment, okay, and the value would be here dev. Okay, let's save this. So you can do this for all of your instances, right, one by one, by adding one tag of environment dev. You can do it while launching as well, but I just missed out on that, so I'll be doing it manually right now. Okay, so I've added tags to each and every instance over here. Right now, what we are going to do is we will be going to the systems manager. What I'm trying to do here is system manager will provide us, best way of managing our EC2 instances, or the on-premises servers as well. But here we are just worried about EC2 instance as of now. So what I want to do is I want to run the script, but I don't want to, run script individually on each resource or each EC2 that I have. I want to run it at the same time on all the instances that I have. So onto the systems manager, on the left hand panel, if you see, you will get the run command option under node management. So in our coming modules, we are going to understand all of these. What is operation management, application change management, node management, right? We are going to understand about all these different types of management that system manager provide us. But right now I'll be going to the run command over here, right? So you'll understand that it is centralized way of managing all our EC2 instances. So here what I'll do is I'll simply click on run command. Okay, and you have different commands over here for different platforms. Like you can apply Ansible playbooks, you can apply the chef recipes, right? You can configure Docker. Anything that you want to do, you can do it over here. But basically I'm trying to run a shell script command, so I'll just search for shell and I'll select this. run shell script. Okay, this is what I want to do. And what are the parameters over here? The command parameters. So basically, what I'll do is I'll be just putting the Apache Tomcat on these servers, right? So I have a code already for that. I have the script already. Just let me take that and paste it over here. So this is the script that we have for installing the HTTPD. Right. So this will be automatically starting HTTPD on our EC2 instances. Right. So this is it. If you want your command to be running on, any particular working directory, then you can do it over here. But, because we are just installing the HTTPD server, so it's not required here to specify the working directory. You can give the timeout and you can specify the instances, right, on the basis of tag, or you can choose the instances manually as well. So we have all these instances over here. But let's say because we have used tags, right? So I'll be just utilizing that tags. So I have this environment dev. That is the tag that I want to use over here. Right. Other parameters are there that while you are running this run command, right? Timeout. Then if you want to put the output, when you install HTTPD, right, it will be giving you some outputs. So if you want to put those outputs if you want to store that somewhere, then you can put it on S3 bucket. But right now I don't want to put the outputs anywhere. I'm okay with that. If you want, you can add the CloudWatch alarms as well, right? You can send the SNS notification. If you want the same command to be executed on CLI, then this is the command on CLI. But right now I do not want it. I want to run it from the systems manager itself. So we'll be clicking on run. Targets are two because, okay, I missed out on showing one thing, that simultaneously we would be running on two targets, right? After it is completed, we'll be running into other two targets. Okay, I'll be showing you that as well. So two targets are successful, as you can see it over here. Right, we have two targets. Now let's see, we are having instance ID CE0P. So I'll go back to the EC2 instances over here. I'll be searching for that instance. Okay, CE0P. See, this is the one. So I'll just click on this and I'll check whether the HTTP is installed or not. So I'll just copy this public IP address. I'll add this new tab and I'll be running this particular command. And it shows it works, right? So basically, yes, it is being installed onto our EC2 instance. Right. Now, why just two instances were, selected, and only on two instances we were having this installed is because, see, this is the other instance. It shows it works, right? Now let us see on the third instance. It be this public IPv4, and if I paste it over here, then this will actually not work, right? Site cannot be reached. So now I'll go to the EC2 instance over here. Not the EC2, basically we'll be going to the systems manager and show you that why this happened. I'll scroll down under the node management. I'll click on run command, right? And we'll be again searching, or let's say we'll be running the command over here, right? I'll search for shell. I got this run shell script. And if I go down a little bit into the rate control, okay, so 50% of target was selected. That's why the command got executed on two of our targets instead of four, right? So you have to change it over here to 100% for running it on all four targets, right? So that is why only two targets were being targeted. So we'll go back into the run command, and into the command history you can see this number of targets were two. There were no errors over here. So what I can do is I can select this again and we can select on rerun, right? If you want to rerun it, you can rerun it as well. But this is what I wanted to show you, that you can have a centralized management of EC2 instances with the help of systems manager. This is one of the demonstration for the same. So we have seen so many things into this module, right? We have understood about infrastructure as code. We have understood about cloud formation. We understood about different methods of deploying our infrastructure, like, elastic beanstalk was there. Then we talked about solution library. We talked about CDK. And lastly, we talked about systems manager. So all of these are somehow helping us, in maintaining our resources correctly or for infrastructure as a code. Lastly, we have seen the demonstration of all of these, right? So demonstration of cloud formation, elastic beanstalk, and systems manager, right? So this is how the things work when you want to automate them on AWS. It becomes easier for managing the resources. So it is quite, popular nowadays for using infrastructure as a code. So that's it for this particular module, everyone. Thank you so much.